All right, here are solutions for the first quiz for Math 251. Solutions. You're given this graph, this kind of weird graph that I found on Google Images, and you're asked to sketch the secant line to g, I guess I'm calling this function g, from x1 equals -5, so it looks like that's talking about this point right here, to x2 equals -3. So it looks like that's talking about this point right here. So all it's saying is take this point and take this point and connect them with a straight line. Straight lines are not the easiest thing in the world to do on a computer, but I'll call that good. Maybe I'll say in blue, and then I'll probably forget to print these in color, so you'll have no idea what I'm talking about. And then calculate its slope. Fine, I can calculate the slope. The slope of the secant line, you don't have to write m secant, you can just write m, is equal to the change in the y coordinates divided by the change in the x coordinates. y2 minus y1 over x2 minus x1. Well, two of those points are given. x1 equals -5 and x2 equals -3. I could find y1 and y2 by looking at my graph. X1 equals -5. Y1, it looks like it's equal to -6. The y coordinate at this point appears to be -6. Y2 is asking me what's the height, what's the y coordinate when x equals -3. That appears to be -10. Take those four pieces of information and plug them in down here. Y2 was -10 minus y1, which was -6, and divide that by x2, which was -3, minus x1, which was -5. Sorry about all the subtracting negatives. -10 minus -6 is the same as -10 plus 6, which is the same as 6 minus 10, which is equal to -4. -3 minus -5 is the same as -3 plus 5, which is equal to 2. And -4 divided by 2 is -2. So the slope of the secant line is equal to -2, which looks about right. It looks like this thing goes down by 2 every time it goes over by 1. Sketch the secant line to g, calculate its slope, done and done. Sketch the tangent line to g. Okay, better change colors. Maybe I'll say drawn in red. At x1 equals -2. First find that point. That's talking about this point right here. The tangent line is the line that just kind of touches at that point right there. Yeah, that's not great. Let me try again. Maybe I can try again. Just kind of touches at this point right here. Doesn't go through my graph. It's not the best line I've ever drawn, but I'm going to call it good enough. So sketch the tangent line. That's this guy right there. To g at x equals -2, and visually estimate its slope. Look at this thing and ballpark its slope. It looks to me like it goes up by 2 every time it goes over by 1. Might be close to right. If you say it goes up by 3 every time it goes over by 1, that's fine. If you say it goes up by 1 every time it goes over to, you probably could even get away with that. If you say it's 0, if you say it's negative, no, that's not going to work. Roughly 2. How about this? M tangent equals roughly 2. Make sure you put a positive number in there. If it's not exactly 2, that's fine, as long as you knew what you were doing there. Okay. Explain how you could use different secant lines to estimate the slope of the tangent line to g at x1 equals -2. Calculate. That's not even close to calculate. Let's switch colors. Calculate slope, maybe slopes, of secant lines like as shown in part A. Calculate the slopes of the secant lines because we know how to do that, letting x2 get close to x1, which is equal to -2. So calculate a whole bunch of secant lines, and as the 2 points get really, really close together, that will become close to the slope of the secant line will become close to the slope of the tangent line. It's a horrible explanation here. But hopefully you know what you're doing enough that you don't really need this part in the solution. Calculate slope of secant lines letting the second point get close to the first point is essentially what I'm saying here. And then finally, part D says, using your slope estimate from part B, that's a problem. No, that's right. Slope estimate was up here in part B of 2. So slope estimate from part B, I got m equals 2, and I'm going to say your answer may vary. Slightly. Using your slope estimate from part B, find the equation of the tangent line to g at x1 equals -2. Well, what you need to know is that when x1 equals -2, y1 is equal to, let's see, it looks like -9. Right? We're talking about this point right here. So I have a point, -2, -9, and a slope, 2. I can take point slope form, which is y minus y1 is equal to m times x minus x1, and plug stuff in. Y1 is equal to -9, so I got y minus -9, aka y plus 9, and that's equal to m times x minus -2, aka x plus 2. So I got y plus 9 equals 2x plus 4, so I have y, maybe on this row, that's unfortunate that all erased, y plus 9 equals 2x plus 4, so therefore y is equal to, if I subtract 9 from both sides of this equation, 2x minus 5. You can check that and make sure that makes sense. 2x minus 5, so the y-intercept is -5. Yeah, that looks about right. My line in red right here, it looks like it crosses the y-axis right around -5. So you'd come up with something like that. Not the greatest quiz because you'd have to estimate your answer in B, and if your answer in B is different, that's going to change your answer in D. As long as your answer in B is close, you shouldn't lose any points for D. If your answer in B is way off, then maybe you lose points for it up here, but if you can still show you know what you're doing in D, you should get at least most of the credit for down here. But I guess I'll call that good enough, and I'll end this video here.